Welcome to Matematika. Today we're going to do problems and solutions of rate of change in linear functions and quadratic functions. I'm dividing this video into two parts because there are a lot of problems and solutions that are related to the rate of change in linear and quadratic functions. So we're going to start with problem 1. A car rental company charges a daily rate for renting a car. The following table shows the total cost in dollars of rental a car for a certain number of days. So you are given a table here, the number of days, that is the x value, and the total cost, which is the y value. I marked it already because the question is asking what is the average rate of change of total cost between x equals 1 and x equals 5. So I mark where the value of x equals 1 and the y value is 40, and when x equals 5 the y value is 160. Of course, doing the rate of change, we can do the rate of change formula, the change in y and the change of x. So y2 minus y1 over x sub 2 minus x sub 1. So your y sub 2 is 160 minus y sub 1 40, x sub 2 is 5 minus 1. So we have 160 minus 40, that's 120, over 4, you have 30. So that means that the average rate of change is $30 per day. Okay, this answers the first question. Second question, you are asked to graph the points from the table. By graphing, okay, the graphing is shown. This is the cost of renting a car for the y, and this is the number of days. This is the x value, the number of days. Okay. Now, analyze the given data, that's a table of graph, to observe the patterns or relationship between the number of days and the total cost. All right? As the value of change of the cost is staying constant, it's constant. Why it's constant? We start here 40. Then it is 100. So I mark here 40, 100. Then it is 160. Then you have 220. Then you have 280. So by looking at that, you will know right away that it's, for the number of day, one day, you have 40 in the table. Then for the third day, you have 100. So the rate of change of the cost is staying constant. This is because the relationship between the number of days and the total cost, okay, is linear. This is linear. So that means the rate of change here is constant. As observed from the graph of the points, the linear relationship, the rate of change remains constant throughout. Okay. Is the rate of change of the cost increasing, decreasing, or staying constant? As calculated, right? We calculated the average rate of change to be 30. We have that average rate of chains is $30 per day, which represent the constant rate which the total cost increases. Okay? The cost increases with respect to the number of days. Okay? The more days you have, the cost increases. So that's why we have a linear relationship there. Okay? So for additional day, of course the total cost will also increase by the constant amount of $30. So that means our rate of change is increasing as the total cost increase with respect to the number of days. So the more number of days, the more the total cost will increase. All right, let's have a problem here. A marble is dropped from the top of skyscraper from a height of 1,800 feet. The height of the marble in feet and t in seconds after it is dropped is given by the function of h of t equals 1,800 minus 16t squared. You are asked to complete the table. Okay? T in seconds, 0, 2, 4, 6, 8, and you have h of t in terms of feet. So we're gonna apply the time with respect to the function. So h of, let's say I start when the time is 0. So 1,800 minus 16 t squared, that means 0 squared, is equals to 1,800 feet. So that means this is 1,800. Okay? I think I'm gonna draw a line right here. Right. Next, when h is 2, so 1,800 minus 16 times 2 squared is 2 squared is 4 times 16, then subtract from 1,800. So that would be 1,800 minus 64. That's 1,736 feet. All right. When h is 4, you have 1,800 minus 16 times 4 squared. That would be 4 squared is 16 times 16. That is 256. You subtract from 1,800, that would be 1,544 feet. So this is 1,544. When it's h of 6, so 1,800 minus 16 times 6 squared, it's 1,800. 6 squared is 36 times 6, 16. That is 576. So you have 1,224 feet. So when h of 8 time is 8 seconds. So 1,816 times 8 squared, that would be 1,800 minus 1024. 8 squared is 64 times 16, that's 1024. You have the value of 776 feet. Okay? You are just asked to complete the table. Now the table is completed. Question letter B. Find the exact time when the marble reaches the ground. Okay. I said I always, when we solve problems like this, it is, you know, it is good to make a sketch of what is going on. Let's say, for example, the marble is, oops, is letter B, right? Okay. Let's say the marble is somewhere here in the beginning. It is dropped, drop, drop, drop. Say this is the ground. Um, this is at 0 time. This is the time when it's 2 second, 4, 6, 8. Then this is the ground. When it hits the ground. Okay. The question is, when it reaches the ground, what is the time when it reaches the ground? Take note that from the function h of t is 1800 minus 16 t squared, right? The time here, when it reaches the ground, the time is 0. No more time. So that means it's 0 minus 16t squared. Okay, transpose 16t squared to the left, that will become positive. T squared will be 1800 over 16. So t squared is 1800 divided by 16, that's 112.5. Okay. So how will we take out the square sign? By getting the square root on both sides to take out the square. So t would be the square root of 112.2. So approximately 10.6 seconds. So after 10.6 seconds here, the marble reaches the ground. Okay? Find the average rate of change in the marble's height during the total length of its drop. Average rate of change from top to down. Okay? So remember that when, from the slope formula, isn't it the rate of change y? Change in y is over the change in x. Remember our y from the table, that is from the table, that's the height, and t is the time. Okay, so this is the change in height over the change in time. What changes of height would that be? So that means from initial height to the final height. When the ball reaches here, this is the final height right here. Final height. From the beginning, that's the initial height when the marble was thrown down. I could write it here. Initial height. Okay. So that means we could get the change in height by subtracting the final height minus the initial height. And the time would be final time also, change of time, when the time when the ball is on the ground, and the initial time. Okay, let's look at these changes right in the situation. All right. Because we have this distance from when it's 2, when it's 4 seconds, when it's 6, when it's 8. It's found in the table. We solved that already. What are the height at that particular time? So let's do the height, change in height. Final height is 0 when it reaches the ground. And the initial height is 1800 at the top. Then final time, okay, when time it reaches the ground, it's 10.6 seconds. And when it is at the top, the time is 0. Right at the top, the time here is 0. So you have 0 minus 1800, that's negative 1800, and then 10.6 minus 0, that's 10.6. So dividing, okay, this is the average rate of change. Average rate of change. Okay, how much would that be? Negative 1800 divided by 10.6. We have a negative 169.81 feet per second. That's the average rate of change in the marble's height during the total length of its drop. Okay, it's approximately negative 169.8. Why it's negative? On the relationship, negative sign indicates the height. Why it's negative? The height is decreasing, right? As the marble falls. Imagine, we have the height here. When it's 2, it's 1736. Move down. After 4 seconds, it becomes 1544. After 6 seconds, it's 1224. What have you observed? It becomes smaller and smaller. It's decreasing until the height reaches at 0. That's why you have a negative average rate of change. All right. For letter D, complete the table, okay, with the average rate of change as the height of the marble. Okay, of the height of the marble. Now you are given a time interval. So your interval is 0 to 2, 2 to 4, 4 to 6, 6 to 8. With respect to the average rate of change over that interval. Okay. So I will go back to the function. H of t is 1800 minus 16t squared. Because we have interval here, I'm going to mark this as interval 1, 2, 3, 4 intervals. All right, let's start. Let's get the interval of each. I'm going to start with interval 1. Our interval 1 is between 0 and 2. All right, so start with h of 0 and h, it looks like an A. H of 0 and H of 2. Okay, 1800 minus 16 times 2 squared. This is 0, I mean. right? So that would be 1800. 1800 minus 0, that's 1800. How about when it's 2? 1800 minus 16 times 2 squared. We have that value. I think we computed that value over there. We have 1736 when at 2 seconds. So let's get the rate of change here. That would be, this is y2 minus y1, x sub 2 minus x sub 1. So our y2 is 1736 minus 1800 over 2 minus 0. So what do you have that? Let's compute. That is 32 feet. All right. That's negative 32. Let's do interval 2. 2 to 4, the interval. So h of 2 and h of 4. I think we have the computation of h sub 2. I might write it as well. All right. And h of 4, 16 times 4 squared. That would be 1544. Okay. So this is your y2, y1, x2, x1. So your slope rate of change would be 1544 minus 1736 over 4 minus 2. Okay, you have a value of negative 96. This is feet. You have feet. All right. This is this is feet, 32 feet per second, 96 feet per second. Okay? Because that is over the time. The next interval 3, that is 4 to 6. So we have h of 4 and h of 6. So we have already h of 4. That is 1544. And our h of 6 is 16 times 4 squared. We have 1224. Okay, let's get the slope. The average rate of change, that would be 1224 minus 1544 over 6 minus 4. And that is equals to negative 160 feet per second. Okay. All right. So I could put a negative 160 here. And the last interval, we have, that's interval 4. That is 6 to 8. H of 6 and H of 8. So you have 1800 minus 16 times, oops, I think I made a mistake here. I was looking at it. This is 6 squared. Okay, anyway, the computation is there is correct. 6 squared, which is equals to 1224. This is 1800 minus 16 times 8 squared is 64. We have equals to 776. So in getting the slope, we have 776 minus 1224 over 8 minus 6. Remember, 8 minus 6 is 2. So you have the value of a negative 224 feet per second. Right, so this is negative 224 feet per second. What is the average rate of change? That is in terms of distance over time. All right, the table is completed. Plot the points on the graph. Okay, we have the table here. I mean, the graph here is plotted. So let's trace the graph. If I trace the graph like this, I think the graph form a curve. Okay, the curve is somewhat like facing down. Okay. So that's the graph. Basing on the graph, that is for question F. Sorry, is the graph of the graph is concave up or concave down? Okay, so you could say when you do like this and explain something, you have to write it in terms of words. You would say the graph of the function h of t equals 1800 minus 16t squared. Do not just say concave down or concave up. You have to be specific. What are we talking about it? We're talking about the graph of what? Graph of the function h of t is equals to 1800 minus 16 t squared is concave down. That is how you should answer it in a test. For example, you are given a test. So, what can you say about it? Well, it's the graph is facing down. It's concave down. All right. I think that's it. Oh, we have what does it means in the context of the problem. So, it is because, okay, one thing, if you're not looking at the graph, you're just looking at the, at the function. Remember, I told you when the variable is in the power of, to the second power, you could tell right away that the graph, the function is a quadratic function, right? When it's to the first power, of course, it's linear, Okay? So we could say that the t squared has a coefficient of negative 16. Okay? So this is negative 16 is the coefficient. If we're not looking at the graph, coefficient of t squared, what does it mean? It's negative. Say it's negative. Which, when it's negative, it resulted to what? Resulted, okay, if you remember the concavity, when we did concavity, it's downward and then opening downward, parabola. Okay, it's positive when it's, opening upward, parabola. So in context, start writing down, since it's asking about concave. When you are writing down your, you want to prove on something, and what does it mean in the terms, in the context of the problem. So you would say that the concave, okay, start saying about the concave down indicates that the rate of change, what can you say about the rate of change when it's concave down? Rate of change of the what? Of the height of the marble is not constant, right? Height of the marble is not constant, because as it moves, the marble moves down, going down, as the marble falls, the marble rate, this is rate of change, marble falls. As it falls faster and faster, very fast, as time goes. What do you think? What's the reason? Due to, in physics, acceleration as an object that is moving down towards the ground, due to the acceleration of gravity. So the concave down shape of the graph visually represent the increasing speed at which the marble is falling over time. Okay? So we could say the concave shape of the graph you could say visually we could see it. And what does it represents? The increasing speed. The speed is so fast at which the marble is falling down. Is falling over the time. Over time. You can write your if you are asked in terms of the context. So as I've said, start writing what the word you can see in the problem. So it says concave down. Start writing about what does the concave down is talking about, or how is it related to the speed of the marble with respect to time. And you know, the concavity, when it's decreasing, you know, like the height of the marble as it goes down to the ground, it is decreasing. So when it's decreasing, it resulted to a concave down. All right. We'll pause for this and then we will continue on our part 2 of the solutions, problems and solutions. So I would like to say that if I can do it, so can you. Okay, please don't forget to hit the like button and hit the subscribe button. See you on my next video.